example 5 is just taking what we've worked on the first 4 examples and kind of puts it all together. So we're gonna function, and then it translates to the g function. It's asking for the equation of the g function. We're gonna, before we can write it as ax squared plus bx plus c, we need to write it in vertex form first. So the first thing we're going to do is just understand how it's translated. So it started at the origin, but then it moved 1 left, which is going to be plus 1 on the inside, and then 3 up, which would be the plus 3 on the outside. The next thing you want to do is find the a value, the value that goes in front. We know a is positive just because it opens up. That is clear. But we don't necessarily know if it's, a number, an integer, or is it just 1. So let's take a look at how you could figure that out. 2 ways. Let me talk you through what the book is telling you to do, and then I'll give you a shortcut. But the safest way to do it is what they're suggesting, which is find another point on the graph. It says 0, 4 appears to be on G, which is true. That's right there. And then what you can do is substitute 0 in for X and 4 in for Y and solve for A like we were. And when you do that, you get that A is equal to 1. The other way, you can pretty much just get this right off the graph. So if the vertex is here, if by going right 1, you go up 1, that's your A value. That means 1 is your A value. Let's say you went right 1 and the function moved up 2, then the A value would be 2. Or if you went up 3, the A value would be 3, but you didn't, you went up 1. So you can pretty much get that A value right off the graph as well. If you're not comfortable with that, just substitute another ordered pair in and solve for A like we had in example 4. Once you have your A value, you can write the equation in vertex form. So it's going to be, once you substitute 1 in for A, you're not going to write it at all. So it'll just be x plus 1 squared plus 3. Then you need to FOIL the x plus 1 squared and then add the 3 like we did in the last example. And what you're going to end up with is x squared plus 2x plus 4. So that is the equation then in ax squared plus bx plus c form. All right, let's take a look at the last one here. 2 parts. Okay, so I would suggest pausing like we have been, and then come back and you can check your answer with me, but give it a try first. All right, so let's take a look. For the first part, it says 2 units to the right and 5 units down. It says nothing about stretching or reflecting or compressing, so there is no A value. 2 to the right would be minus 2 on the inside, 5 down is 5 minus 5 on the outside. When you FOIL the x minus 2 squared and then subtract the 5, you get x squared minus 4x minus 9 for the ax squared plus bx plus c form. For the second part, you're just starting with y equals x squared. When you reflect it, you make it the negative x squared, okay? And then there is no horizontal translation, so there's no need for parentheses. So there is no difference for this one between the vertex form and the ax squared plus bx plus c form. Then translating it 1 unit down is the minus 1 that's on the outside. So it's just y equals negative x squared minus 1. And again, that counts for both forms. All right. I want you to try the exit ticket, and then we will go over that in class we'll start class with that tomorrow. Let me know if you have any other questions, and tomorrow we'll also have time to do the practice.